All right, so here we have the graph of a piecewise function. We don't actually have the equation for it, but you probably can figure out what it is if you think about it. So our domain, we've got our arrows here, oops, again, all the time, on both ends, so our function keeps going. The only thing we need to worry about is at this x equals -2, and since we have a closed dot and an open dot, we don't have any issues. This function exists for all values of x. So we're going to say all real numbers, aka -infinity to infinity. All right, so next we got to look at our range. So remember, we're going to kind of travel up the y-axis and say, hey, does my function exist? Does my function exist? No, no, no. I get to 2, and it's like, no, it doesn't exist there, but it's going to exist right after that. So we're going to say, okay, 2 is not included, but everything above 2, for at least a little while, is going to be included. Now, does it keep going above 6? Why, yes, it does, because this line is going to keep going, right? So we're going to go all the way up to positive infinity for our range. All right, so evaluating, all we've got to do is read the input, go to that location, right? So f of -6 means the x input is -6. We're going to travel, in this case, up to see what our function value is, which is 6. So there we go. We're going to do the same thing at -2. We're going to go out to -2. We're going to travel up. Okay, we're not going to stop here because that point's not included. We're going to keep going and say, yeah, we've still got the point -2,6 is on our graph. What about f of 0? We're not going to go anywhere. We're just going to head up till we find our function, and we're going to see that it's at 3. So our y value is 3. That's our function value. And then the last one, we're going to go over to x equals 4. There we are. And we're going to travel up till we hit our function, which I can't draw a straight line. And we can see the point on the graph when x equals 4 is 5. So there's our output, 5. So these are really simple. Hopefully, you just got to pay attention to which part of the graph your input falls on. So here we've got another one. We've got for x greater than 4, we're using the function 4x minus 6. And for x between -2 and 4 inclusive, we've got the graph of x squared. The graph doesn't exist for any x values less than -2. So -2 is our, so these are kind of in the opposite order from maybe you would normally see. So -2 is our lowest x value, and our highest x value, this one's going to go off to infinity. Oops, can't draw infinity. So there's our domain. For our range, we really should sketch this thing. All right, so let's do that. Okay, so we can say, we can kind of make ourselves a little table here. Let's say over here. So x, f of x. We could say -2, -1, 0, 1, 2, 3. We don't even need to do all this, right? So -2 squared, that's going to be 4. -1 squared is going to be 1. 0 squared is going to be 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Okay, so we can kind of sketch these things in here. Oops, didn't put the right thing there. So 1, 1, 1, 1, 2, 4, 3, 9's right around there, 4, 16 right around there. So we play connect the dots on that. Now, both of these endpoints on this part are going to be circles, closed circles rather, because those endpoints are included. So I'm going to just do my best here. Didn't quite get there. So there's good enough part of our graph. Now the next part, of course, we're going to say, I'm going to just continue on with a second XY table. And we could say, okay, when x is 4, 4 times 4 is 16, minus 6 is going to be 10. So this one is going to be an open circle, though, because it's not actually included. And we know the slope on this is 4. So over 1, up 4, over 2, up 8, right? So over 2, up 8. So this thing's pretty steep here. There we go. There's the rest of our plot. So now we can see the range pretty quickly, pretty easily, that the lowest point on our graph is at 0, and that's included. And the highest point, so there's no gaps here, right, in my function. For every value of x, for every value of y, the function exists. And in some places, it exists at two places. This is not a one-to-one function. We'll talk about that later. So, but our highest y value, there's no gaps, no jumps here. Highest y value is going to be infinity. And I think that's our last one. So we're done with this chapter.